Right, how about now? All right, sounds good. All right, everybody, I'm here today to talk to you guys about the road to Passkeys meet Ruby. My name is Helio. I've been doing software development for 22 years, the past 12 years primarily with Ruby on Rails. And here's the agenda of my talk. I'm going to talk about the W's, what, who, and why, Passkeys iceberg, how it works, maybe some not so exciting demo, some interesting stuff, some fluffy stuff, and the Ruby community. So, but before I start, let me ask you a couple questions here. Oops, too fast. Raise your hand if you ever heard about Passkeys. All right, keep your hands up if you read about it. You went to some other website and you read about it. Okay, pretty much everybody. So now, how many of you all set up your Passkeys in your GitHub account? All right, there's a couple of people here. So I set up my Passkeys on GitHub, I don't know, a couple weeks ago, and I never use it. It's a new technology. It's time to be more adopted now. So let me start by defining what Passkeys are. So Passkeys are replacement for passwords. They've been designed to replace or reduce the over-reliance of passwords. It is part of a web authentication standard. It uses public and private key to do a challenge-based authentication. And over the course of the presentation, I'm going to go into more details what that actually means. It uses public key encryption. That was a technology that's been around for a while. And sometimes is protected by device biometrics, sometimes is discoverable. So here is another definition that I like it. And I like this definition because when I was studying about the topic, about passkeys a handful of months ago, this sentence helped me to wrap my head around what passkeys are. And there's a handful of caveats to this sentence or hidden edge cases, but I like it. And it says, a password is something that can be remembered and typed, and a passkey is a secret stored in one's device, unlocked with biometrics. This sentence comes from their website over there, passkeys.dev. It literally comes from a page that's called What Are Passkeys? But here are the caveats, right? My passwords, 99% of my passwords I cannot remember. If I try to type, I'm going to get it wrong all the time. I use password managers, all my passkeys are strong, and all that kind of stuff, right? All my passkeys nowadays, they are also synced with my cloud account. They are not only on my device. And all my passkeys are unlocked with biometrics, but maybe not all of them are going to be unlocked with biometrics. But I think this sentence speaks to the majority of the users that still remember and type their password. And they write it down in a Post-it, or they write it down in a notebook, or they put in the notes app in their cell phone. And there is one scenario of passkeys that a passkeys can be created bounded to a given device. And like I said, all my passkeys are unlocked with biometrics, but probably not all of them are going to be. So maybe in the future, there's going to be some discussions between what's passkeys and what's biometric passkeys. But maybe time travel is going to help us answer that question. So here is a little picture from the past, right? Somewhere around May 2016, the first public working draft of web authentication standard was released. Folks from Knock Knock Labs, Microsoft, PayPal, and Google, somewhere in May 2016, released the first version. And that screenshot there is from the URL down there, w3missingnc.org. If you're into reading standards, you can start from that URL. Here, the passkeys iceberg, right? Like I said, Passkeys uses public key encryption, which is a technology that started being created in the 70s. In 2016, the first W3C web authentication standard was published. And you have all these acronyms below the water level and all of those above the water level that they all play a role so passkeys can be a reality and our users can have a more strong, secure replacement for passwords. And my talk here today is that small little red shape over there. But this gives you, if you are if you are a software developer adding passkeys to your web application, you are all the way there to the top of the iceberg. But this gives you a little bit of an overview of all the moving pieces that are necessary for passkeys to work in your web application. And this is a sentence that I like, that I feel like defines passkeys well. Passkey is a public and private key pair protected by your device biometrics and used for challenge-based authentication. So let's break that down in small sentences and look at each one of them individually. Passkey is a public key pair. When you create a passkeys, you are actually creating a public and a private key pair. The private key you use to encrypt your data, the public key used to decrypt your data. And the private key stays on your device, sometimes it's synced with your cloud account, and your public key, you give that public key to the website that you're creating these passkeys for. Protected by your device biometrics. Before you get started on your passkeys flow, the first thing that your device is going to do is to validate your biometrics. Your Touch ID or your Face ID on your laptop, or your Touch ID or your Face ID on your cell phone. And used for a challenge-based authentication. What this means is that in the world of passkeys, you just don't show up in a website and say, hey, website, here is my login and my password, authenticate me. That's not how it works. So when you go sign in a website using passkeys, the website is going to challenge you so you can prove that you are who you are and you are not an impersonator. So the website is going to send you some data and it's going to ask you to encrypt that data with your private key. So you encrypt that data and then you send your digital signature back to the website. And the website, using the public key that they store during the registration, is going to decrypt their password. And if it checks out, voila, you're authenticated. So now let's look into more details how it works, right? I'll talk a little bit about registration authentication. Re-authentication is just whether your passkeys or password is just a matter of going to the authentication flow again. And so I will focus on registration authentication. And in the world of passwords, we all know how these work, right? So we use that every day. So I'm not going to talk much about it. Registration. So here we're going to talk about these 4 different entities. spkeyman.com, which is just a website. In the world of passkeys, that's your relying party. That's how it's called, or RP. That's a very, very passkeys friendly website. I can assure you that. Sorry for the shameless plug there, but that is your website. That's your Rails application, right? And your user, but remember, your user, your browser, and your operational system. It's not only you. Your device biometrics. I'm using a representation of your cell phone, your Face ID. It could be your laptop with a Touch ID, or your cell phone with Touch ID if you use Touch ID instead of Face ID in your cell phone. And your cloud account, right? So here's how it goes, right? So you go to a website, and I wanted to sign up, and the website is going to say, hey, please send me your public key. Yes, sure, I will create one passkeys for you for this website. So I'm going to ask my device to create a passkeys for me for that specific website. So the first thing that device is going to do is your biometrics. It's going to validate your biometrics, and so once your biometrics is validated, it's going to create a private and a public key for you. Your private key gets synced to the cloud account, and your public key goes back to your browser and then goes back to the website. And then the website, okay, good. You give me your email or your username, whatever authentication key you use, and your public key. Your account is created. You're good. This is simpler and more intuitive than passwords, because pretty much between the steps 1 and 7, the only thing that the user needs to do is to give consent and allow your device to initiate all the passkey stuff. And you need to validate your biometrics. And Passkeys now is current support for all the big players, Google, Microsoft, and Apple, Google, and Microsoft on Apple laptops, Windows laptops, iPhone, Androids. Unfortunately, Mozilla and Firefox are the only ones, the key players, lagging behind. So now that you have an account using Passkeys and you have your Passkeys, now you go to the website and you want to authenticate, right? So this is how authentication look like. You go there, you want to sign in, and then now the site is going to ask you to sign a piece of data using your private key. It's like, okay, all right, I'm going to do my things here on my device. I'm going to do the validation. And once my biometric is validated, my Face ID is validated, then my device is going to access my private key and is going to sign the data. and then it's going to send that back to the browser, and the browser sends back to the website. And what's going to happen here is the website is going to get the digital signature, is going to look at your private key or your public key, and if it decrypts that signature and if it checks out, voila, you're authenticated. So your session is authenticated, you're logged in into that system. So some interesting things that I wanted to highlight here. Sites don't store critical authentication information anymore. What happens if my site.com database gets leaked? The information there is your username and your public key. With that information, nobody can impersonate you. Nobody can answer the challenge-based authentication because they would need your private key. And your private key is now on your device or is stored with your cloud account. So good luck trying to break into their system to get my private key. They're unique per site by design. This is baked into these standards and guaranteed by your browser and your device. They're strong by design. Again, it's a public and a private key using public key cryptography. But now your browser, your operational system, and your device, they are the ones touching your private key, managing your private key, and replicating your private key. So whichever device you use, Apple, Google, Microsoft, we are trusting them now to keep our private keys private. They are the ones on the hook now. You guys ready for demo time? Yeah. All right, let me see if I can do this. Okay, that's it. So this is a Rails application. It's use device and uses Passkeys. And this is a thing that I created not too long ago. And basically what this does is I'm just going to demonstrate to you guys here. Those diagrams, right, they seems a little too complicated. And I'll show you what registration and authentication looks like in the world of Passkeys. This is a prototype that I created for a hackathon a few months ago, and it only uses Passkey. It only demonstrates Passkeys functionality, right? So let's do th at helio.ruby, and I'm going to just put a label Safari. I'm creating Safari. So this is the sign up. Look, I put my email and I put a label. That's it. That's all I'm going to do. I'm going to click sign up. So now here's what happens, right? So the browser is going to initiate the Passkeys process, right? All those things that I put in the diagram, and it's going to ask my biometrics. What they're asking here is like authenticate you and allow me to create your private key and sync your private key with your cloud account. And if I put the right finger here that I have on my laptop, I get authenticated, and voila, my account is created. I don't need to type password. I don't need to make sure that it's unique and strong or anything. Everything got created. And let me show you here real quick what re-authentication looks like, right? Let's imagine that my application implemented a feature where changing my name is a sensitive transaction. So before I change my name, I'm going to re-authenticate Helio and make sure that it's really Helio here. It's a sensitive transaction. I'm going to re-authenticate. I'm already signed in here with Passkeys, right? So I'm going to do the authentication again. And then I'm going to put my finger, and then it authenticates me, and then it allows me to change my name, right? So now that's registration and re-authentication. So if I sign out here and I get signing back again, this is what happens, right? So it shows me the little self-discovered. It shows me the accounts that I have. This is running on my laptop. So I have a bunch of accounts here. There is one that I tried yesterday when I was doing, oh no, this is the one that I created today, right? I think this one here, I think I created yesterday. I was kind of doing a rehearsal of my talk. So I think this is the one that I created today, right? Yeah, Helio.ruby. So I'm put my finger, and it's going to do all those things. Public key, private key, sends the data, encrypted, decrypted, and then authenticates me that I showed in the design, in the diagrams. And that's it for the demo time. I can believe it, everything worked great. Thank you. All right, the fluffy stuff. Let's talk about the fluffy stuff, right? Passkeys are intuitive. Come on, intuitive. Passkeys are intuitive. You guys all see that, right? It's so simple. I just need to be me and have my finger with me, right? As far as I know, everywhere I go, I carry my finger with me or my face, right? So, but remember, during the sign up, the only thing the user does is to give consent to your device to do the passkey stuff, create your private key and store that with your cloud account. During sign in, passkeys are discoverable, but to some extent, they are discoverable in a similar fashion that your password manager discovers your credential when you navigate to a given website. So there's not much innovative stuff there. They are automatically unique per site. I already said that. This is baked into the standard in your browser, and your OS helps you ensure that. It is breach resistant. Remember, if mysite.com database gets leaked, the information there is your username or your email and your public key. Nobody can impersonate you with that information. And it is phishing resistant and protected with your biometrics. If you saw the demo here, notice everything, the whole passkeys process, creation of private key and synchronization, everything is automated. As a matter of fact, I don't know what sequence of characters my private key is. So if someone try any phishing techniques against me to try to steal the information, they're not going to do anything. Imagine like a bad guy start calling every phone one after another, right? And then someone calls me and I pick up my phone and say hello, and the guy on the other phone keeps and tell me, go and say something like this. Helio, I am your father. You know, that funny voice. Helio, I am your father. Give me your private key. So if someone calls me like that and say that, it's like, it doesn't matter whether that person is my father or not. I don't care, right? I don't know my private key, so I can tell him the private key, right? But jokes aside, passkeys are not vulnerable to any social engineering technique to try to steal that information from you, because the process is automated and your passkey is not controlled by you. Your private key is not created by you. You don't create your private key saying, oh, my private key is 1, 2, 3, 4, 5, 6. So they can't steal that information from you. I guess after that joke, that's not fluffy stuff. That's some good stuff, right? And there is more. There's a lot more to passkeys. There's discoverable and non-discoverable. In your website, you can decide to build a scenario to implement a support for non-discoverable passkeys. There are device-bound passkeys. This is an interesting one, but there's pros and cons. So if you create a device-bound passkeys, that passkeys is good only for that device. If you lose that device, that passkey is as good as nothing, because you can't use that anymore. You would have to have a manual process to recreate a new device-bound passkeys for your new device that you just bought, and then use that to access whatever system you have. This is not going to be the most passkeys that we're all going to be using. The most common passkeys is the one that I showed in the diagram, where your private key is going to be synchronized with your cloud account. So if I lose my device, or my cell phone dies, I will buy another one, right? I still can't live without my cell phone. And I will buy another one. It's going to be the same one, right? I lost my iPhone. I'm not going to buy an Android, but there are some scenarios that even that is supported. I will buy in another iPhone. I'm going to key in my Apple account, and voila, all my passkeys are back. There is autofill UI. These are really interesting stuff. I really wish I could dive deep into more of that. I definitely recommend you guys check it out. The fact that there is a W3C standard that discuss and define requirements about UI and UX, it's freaking amazing. There's cross-device authentication. There's roaming authenticator, user presence, user verification, user verifying roaming authenticators, and there is more. All these terms comes from that website over there, passkeys.dev. There is a terms page. That URL is definitely a fun read. I definitely recommend you folks check it out. Why we need passkeys? I guess in this audience here, I don't need to beat passwords too much, right? We all know passwords are problematic. The most common passwords are very easy to guess. This is a study from NordPass, and with the most common passwords between 2019, 20, and 21. If you look at 2022 and 2023, they all look the same. Nothing changed too much. If you look, you find other sources of the same report. They all look the same. The most common passwords are very easy to guess. So I will skip passwords. I don't need to beat passwords too much here, right? But there is all these other things, right? Authenticator apps, SMS, OTP, codes that you send by email, magic links. All of these are cumbersome and not easy to use. We get along with these things because we use our computers every day. We use these every day. We're more tech-savvy people, but these solutions does not reach the vast majority of the population that uses those common passwords and write their passwords in a post-it. And as a matter of fact, magic links and emails, the password of my email is 123456. If you send me a magic link, someone is gonna get that information and impersonate me on some websites, right? All right. So far, that's kind of all the passkeys that I wanted to share with you guys today. So I couldn't be in a Ruby community in a Ruby conference without talking about the Ruby community, right? We all heard Matt here yesterday saying that we need to feed the community. So I'm going to spend the last few minutes of my talk talking about the Ruby community. And I want to give a shout out to the Passkeys trailblazers in the Ruby community. So I'm going to talk about Gonzalo Braulio from Cedar Code, Peter Lavica, and Thomas Cannon. So Cedar Code is a web agency based in Uruguay, South America, and they created this gem, Web of and Ruby. If you're doing passkeys on a Ruby on Rails application, most likely this gem is going to be in your gem file or gem file lock. According to the gem-spec file, the authors of the gem are Gonzalo Rodriguez and Braulio Martinez. Gonzalo released the version 000 of the Web of and Ruby gem May 9th, 2018. You guys get it, right? May 9th, 2018. He was like 5 days away for some legendary coincidence. It's like, I can't believe it. May 9th. Anyway, jokes aside, they also have a Web of and Rails demo app. It's live. You can go to that link and check it out. It's pretty much what I showed you guys. Registration authentication using passkeys. And the last release of that gem is V300, released in February 2023. Peter Lavica. Peter is a Ruby on Rails developer, and in 2001, he wrote this blog called Multi-Factor Authentication for Rails with Web of and Device. It was originally published at the Honey Badger website, Honey Badger blog, and he also wrote a companion Rails application that goes along with his website. It goes without saying that I definitely recommend you check this article. It's a very nice read, very well written, and I learned a lot about passkeys a handful of months ago reading his article. And at last, but not least, Thomas Cannon. Thomas is the creator of the Ruby Passkeys GitHub organization. He also created the Warden Web of and gem and Device Passkeys gem. He also created the Rails and Device template application called Device Passkeys template. You can find all those in the Ruby Passkeys GitHub organization. And Thomas is the one person that makes the biggest impact in my own passkeys journey, right? Something like 9 months ago, a blog post about Google adding support to passkeys on Gmail show up on my feed. And I remember thinking to myself, like, okay, so Gmail, I know what it is, right? I have a handful of accounts there. And passkeys, what is that? This was early this year. And I was like, okay, it's something I need to read about it. So I put that in the back of my head. One day I'm gonna read about. So I went on with my life, right? And then 4 or 5 weeks later, a post from Thomas on his social network show up on my feed, and he was like, "Hey guys, I'm just publishing the first public beta version of this gem, Device Passkeys. It's all passkeys, cool stuff. Go check it out, send some comments." And that was like, boom, that's the moment that I was looking for. And the next day I was reading about his gem. And then I started learning about passkeys. And a few months later, I participated in a hackathon in Malaysia where I used passkeys to solve some AML CFT problems. And I got second place. So I was really happy with that. And here I am today, talk to you guys about Passkeys and sharing a little bit of what I learned along the way. Thomas was my biggest inspiration and difference maker in my own Passkeys journey. So, future of Passkeys. What is the future of Passkeys? We don't know, right? So this is a new technology that is promising, in my opinion, and it's has a big achievement to make to replace passwords and make web authentication more secure. But we don't know what the future is going to hold, right? So these could be like authenticator apps that reach us, technologies and tech people, but does not reach 90% of the population that needs password. It's not like we have a crystal ball that we can look at the ball and see what the future will look like, right? But it takes time travel, right? We know that. So our friend Hitoshi, sorry if I pronounce your name wrong, gave some evidences today that with Ruby and microcontrollers, you can time travel. We can go to 1970, and we can also go to 2098. Yesterday as well, there are some speakers here that they gave me some solid evidence that's possible to time travel. But I'm going to give you guys just a short side of this joke. And we don't know what the future of Passkeys look like, but time will tell us. This is it, folks. I want to thank you all for your time and your attention. Thank you all the organizers, the sponsors of RubyConf Thailand. It's really an honor for me to be here. If you have any questions about Passkeys and want to check out the Rails application, you can find me somewhere in the back, or you can find me on the internet. Thank you.